Hi, I'm Vadim Axelrod. This research was performed as part of my doctorate thesis in the laboratory of Professor Garit Yovel in the School of Psychological Sciences and Sagol School of Neuroscience at Tel Aviv University. Humans are exceptionally good in recognizing faces. We can quickly and effortlessly discriminate among hundreds of faces that we encounter during the life. Despite its apparent ease, face processing is computationally complex, and no computer algorithms to date can recognize faces as well as humans do. The main focus of our lab is to understand the neural mechanisms of face processing and how they contribute to face recognition. During past 2 decades, functional MRI research has revealed several brain areas which show a much stronger response to faces than any other object. These regions are activated when any type of face is seen. It can be a face of a friend or a monkey, a drawing of face composed of vegetables, or just a computer symbol of smiley face. Such face selective areas can be localized in every person using a short fMRI scan of about 10 minutes, and they were thought to play a critical role of face recognition. However, the mere fact that these regions are activated when a face is seen doesn't implicate that these regions are responsible for face recognition. That is, in order to demonstrate the role of these face selective regions in face recognition, one needs to show that different faces' identities elicit different neural responses. Surprisingly, despite thousands of studies which explored the neural basis of face processing, to date, only 3 studies succeeded in discriminating the neural activity elicited by different faces, and the conclusion of these studies were conflicting. The goal of the current research was to find out which brain region can discriminate between two face identities. In contrast to previous studies, we used faces of familiar, famous people based on findings that recognition of familiar faces is better. The two highly familiar faces we used are those of the President of the State of Israel, Shimon Peres, and the Prime Minister, Benjamin Netanyahu. To assure that discrimination between the two faces is based on the identity of the face and not low-level image differences such as brightness or contrast, each of two identities was represented by 8 different images with varying face view, lightening, and expression. Our data analysis included exploration of the face selective areas as well as non-face selective cortex in the temporal lobe. In our analysis, we used multivariate pattern classification method, which attempts to decode the two identities based on subtle differences in activation patterns elicited by each of these faces. One critical area that we focused on was the face selective area in the anterior temporal lobe. Given that the anterior temporal lobe plays an important role in memory and semantic processing, previous studies have predicted a central role of the face area in the anterior temporal lobe in face recognition. However, this area has been hardly explored before due to technical challenges in standard fMRI scanning techniques. In the current study, we used a novel scanning technique which allowed us to reveal reliably this unexplored area in most participants. The two key findings in our study were as follows. First finding: we could successfully discriminate between two identities in the fusiform face area. In other words, by looking at the neural activity in the fusiform face area, we could say whether participants saw a face of Shimon Peres or Benjamin Netanyahu. Notably, no other face areas, including the anterior temporal lobe face area, were able to discriminate between two identities. Second finding: face identity could also be successfully discriminated in a non-face selective part of the anterior temporal lobe. This is a generic region which may be specialized in semantic information processing. Taking these findings together, we propose that face recognition is achieved by joint effort of two modules. The first one, the fusiform face area, is responsible for extracting perceptual facial information such as the shape of eyes, nose, mouth, etc. The second one, anterior temporal lobe, is responsible for semantic processing of faces, like who is this person, what I know about him, etc. I would like to thank Levi Edersheim Gitter Institute for my PhD fellowship. This study was funded by Wolfson Foundation and Israel Science Foundation, ISF, for Professor Galit Yovel. The results of the current study permitted to advance one step further the understanding of neural mechanisms of face recognition. We hope that in the future, probably not too proximate, we will puzzle out how the brain achieves face recognition with such an ease.